So the question always occurs, this isn't an easy chapter of factoring. Why do I need to do this anyway? Why do I need to learn how to factor? And factoring is a great tool in Mathland. It allows us to solve bigger, uglier, scarier types of problems. Because if we have a large polynomial and we can factor it, we can then solve that equation, find the zeros, which are really important when you're doing higher level of mathematics. Now, we're not going to be doing higher level of mathematics, but it's still good to know your foundation. This allows us to solve bigger, badder things. It also allows us to simplify bigger, badder things, as we're going to find out next week when we stick rational expressions, which are fractions, and factoring together. You need to know the factoring this week to do next week's. Then we get a little bit of a break, but factoring comes back for the last 2 weeks as well, when we're solving radical equations and when we're solving quadratic equations in the last week before the final. So that's why we need to know how to factor. We're going to be able to solve stuff. How are we going to solve stuff? Well, this is the great thing, because to solve by factoring means that we get to use my favorite property, the zero product property. The zero product property is a very simple property. I think your book actually calls it a law, but I like the alliteration with product property together. It makes more sense to me. But the zero product property is a very simple property, and it allows us to do so much in Mathland, and that's what's exciting about it. Alright, you guys might not agree, but I think it's fantastic. And it's so simple. This is what it starts with. It simply says, if you have two numbers, A and B, multiplied together, so it's a product, multiplication, and it's equal to 0, thus it's called a zero product, product that equals 0, something has to happen there. Now let's think about when we learned our multiplication tables. Any number times 0 was always 0. And 0 times any number is 0. So if I have two things being multiplied together equal to 0, then I know that either A has to equal 0, because 0 times some number is 0, B has to equal 0, as some number times 0 is 0, or they're both equal to 0, as 0 times 0 is 0. That's simply what the zero product property says. If I have two numbers multiplied together equal to 0, then I know one of the two factors has to be 0. One of the two factors, the stuff that's being multiplied together. Let's see this with ugly variables. Say I have a problem like this. X plus 2 times the quantity of x minus 5 is equal to 0. My expression on the left side is already what we call in factored form. It's being multiplied together. And we're set equal to 0. This is different than what we did before because there's an equal sign. So this is an equation because there's an equal sign. It's now a balance. What we did before was simplifying expressions. We're just playing with those expressions so we can see how they work once we get them into an equation, as we do have now. So I have two numbers that are factors, meaning that they're being multiplied together. This is a product. This right here is that A, and it's being times this value right here, which is B. So I have A times B equal to 0. So I have the exact initial setup of the zero product law, or the zero product property. Two numbers being multiplied together equal to 0. Then according to the property, either A is 0, B is 0, or both. So I need to ask myself, what value of x will cause, not because, but cause and effect, cause my A to equal 0? Because A has to be 0. So what's going to cause x plus 2 to equal 0. Well, now this is a little equation. It's a linear equation because our x is to the first power, and we should know how to solve this one at this point. To get the x by itself, we'd simply subtract 2 from both sides. So x equals negative 2. Well, let's plug that back in. If x was negative 2, I would have negative 2 plus 2, and here I would have negative 2 minus 5. Negative 2 plus 2 is 0 times, well, that's a negative 7, but 0 times anything is 0. So my left side would equal my right side of 0, and so it's a solution. X equals negative 2 is a solution. Aha, but it's not the only solution, because the property says that if I have a product like A times B is equal to 0, either A is 0, as we just found, or B is. So what's going to cause the x minus 5 to be 0? Set that equal to 0 to find your second solution. X minus 5 equals 0. To get x alone, so it's solved for, you add 5. Whatever you do to one side, you do the other. Since it's the opposite operation, we end up with x is equal to 5. Well, let's check that back in here. If I have 5 plus 2, let's squeeze that in down here. That gives me a 7 times 5 minus 5. Well, 5 minus 5 is 0. So 0 times anything is going to give me 0, which makes the left side equal to the right side, which means it's a true statement, which means it's a solution. So I have two solutions to this problem. X is equal to negative 2 or x is equal to 5. Those are the two solutions that we were able to get because our equation was already in factored form. Let's try another one. What if I had the quantity of 2x plus 5 times the quantity of 3x minus 1 is equal to 0? Because it's already equal to 0, I'm already in my property form, the zero product property, which states that either the A or the B has to be 0. So once I see that I have a quantity times another quantity equal to 0, I know that I can set the factors. Factors are the stuff being multiplied together. So this is a factor. This is a factor. I can set the factors separately equal to 0 and solve. That's the shortcut way of thinking about the zero product property. So 2x plus 5 would equal 0, or my 3x minus 1 would equal 0. So now I have a smaller problem, a linear equation. These are our two-step equations that I solve separately from each other. This is one equation I solve, this is the other equation that I'll solve. To solve this, we know that we have to get the term with the variable by itself and get rid of any constant or term that does not have the variable. To get rid of adding 5, we subtract 5. Whatever you do to one side, you do to the other side. 5 minus 5 cancels, which is why we did that. 0 minus 5 is a negative 5. Then to get x by itself, we have to get rid of the 2. 2 and an x mushed together means multiplication, so to cancel multiplication, we divide. 2 divided by 2 is 1. 1 times x is x. On the other side, we don't do the division here. We leave it as a reduced improper fraction, always. Never mixed numbers, and don't do a decimal. We don't like them in math land. So that's our answer, negative 5/2. It's less work this way. You didn't have to go to a handy dandy and type it in to get a decimal. You didn't have to do anything else. There is your answer from that side. However, don't forget you have a second one that you have to solve. Here it's 3x minus 1 is equal to 0. Once again, we get the term with the variable by itself by moving the other term by adding or subtracting. Because it was a subtracting one, we do the opposite operation, which is to add 1. And you do it to both sides of your equal sign to keep it balanced. A negative and a positive make 0. 0 added to anything is anything. And now to get our x by itself, we once again have to do the opposite of this multiplication, which is division. 3 divided by 3 is 1. 1 times anything is anything. And there's our answer once again on the other side, 1/3. So our two solutions, x is equal to -5/2 or x is equal to 1/3. Once again, you can plug those back in to your original problem and show yourself how the left side equals the right side, and that's what makes it a solution. It keeps a balanced or a true statement in our original problem. So here's another problem. It's still an equation, so we are still solving it without even having to see the directions because there's an equal sign. However, in this case, our problem is not in factored form. We have a trinomial, or 3 terms, on the left side of our equal sign. The good news is the equation is already set equal to 0. If it's not, the first thing we would have to do is add or subtract any terms from one side and move it all to the other side so that our equation is equal to 0. You have to have an equation, and it has to be equal to 0 to use the zero product property. We don't have a product at this point, so that's why we have to learn how to factor, because we do not know how to solve when we have an x squared and an x. We cannot combine those two terms because they are not like terms. Like terms have the same variable raised to the same power. This has an exponent or a power of 2. This has an exponent or a power of 1. Whenever there's nothing up there, there's always a 1 because the God of Mathland is always with us. So we cannot combine those. So how do you get x by itself when you have an x squared and an x? That's why you need to know how to factor. So we break it apart. We have 3 terms. First thing we look for is a greatest common factor. We don't have one here. We have 1, 2, 3 terms, so we make our 2 sets of parentheses. Do not forget that it's equal to 0. It starts off as an equation. It ends as an equation. What times what gives me the x squared? X and x. Oh, lucky you guys, it looks like I have an easy problem here. -10, a negative tells me I need one of both signs, so it's a positive and a negative. Doesn't matter which one you put first in this problem because we have x and x. So I need 2 numbers that would multiply to 10 but subtract to a -3. Well, that's going to be a +2 and a -5. -5x plus 2x is a -3x. Alright? So now I'm in factored form. Now I have one factor times another factor is equal to 0. That's my zero product property. So now we can do what we did in the last examples. Set the factors separately equal to 0 and solve. Once again, I made it fairly easy on us by making it a simple one-step problem here on both of them, so we can come up with our answer a little bit faster. Those are our 2 solutions. Either x is equal to -2 or x is equal to 5 to solve for this equation. So your steps for solving this week is to make sure that you set your equation equal to 0, and that's by subtracting or adding terms all to one side. Then you factor completely, set those factors equal to 0 and solve it. That's that zero product property. And then check. Show all of your work in solving to make sure that you didn't make a sign boo-boo. We like to just assume things and then we get the signs wrong. So make sure that we check and that we're actually showing all of our steps in solving so that we don't mix up our signs. And then of course, check back in the original, make sure that the left side equals the right side. And that is why we learn how to factor.